Thank you for your patience while we got started. We're going to talk about funding and contributing to natural and unnatural resources. This talk is going to ask you to compare and contrast the way that we as individuals, states, and institutions support our natural and digital resources. And so in order to talk about these concepts, we have to define them. For this presentation, when I say nature, I'm referring to the sum total of Earth's resources, so oceans, waterways, air, soil, minerals, flora, and fauna. Included in this definition is man-made nature. Consider farms or gardens, parks, nature preserves. As a part of living on this earth and using those resources, our society has decided that we should contribute back to nature through things like taxes going to government agencies dedicated to researching and preserving nature, or individual efforts like gardens, trash pickups, no meat, improved vegetation, and recycling. All of that is because of what we get out of resources: energy, oxygen, food. It's necessary, of course, for human and animal life on this planet. So next, we're going to define our digital resources, open source. For this talk, when I say open source, I'm referring to the freely available software that we all know and love, but also its human creators and the communities, the web of software and the interconnection between humans and the digital world. It is because of our global digital infrastructure, a kind of resource in and of itself, that we're able to use and consume natural resources like energy, food distribution, supply chain issues. A large question in open source since its development has been, what do we owe it? How do we support it, fund it, contribute to it in a sustainable way, and what do we need to do to regulate our duties to it? There are specific similarities when we talk about digital and natural resources that would allow us to draw conclusions about the funding and support of both. First is natural selection, as nature relies on the survival of the fittest in order to propagate the strongest genes for the next generation of plants and animals on Earth. And we also see water and minerals adapt to changes in the ecosystem in order to continue producing valuable minerals and resources for the environment. Open source also experiences death and adaptation in projects as well, pivoting and surviving as a fork in a survival of digital infrastructure. There's a lot of interconnectivity, going back to that web I mentioned. Nature relies on itself through the generation of oxygen and hydrogen from our air and water that has been recycled by plants and animals. That's how we regenerate and recreate itself. Changing one part of our ecosystem alters the whole of it. Similar to open source, where projects rely on each other, fork and pull from each other, one project can have thousands of dependencies, making a web of reliance and interconnection. Now, when I say permanence, I obviously mean on a macro scale, as individual projects can be sunsetted or deleted and all organisms die. The stability, sustainability, and endurance of our natural resources and open source software is remarkable and similar. Our society would be irrevocably changed if one resource or the other would not or did not exist as they do right now. Nature is all around us, meaning it's extremely prevalent. It's powering the room we're in right now and the world we're on. It's made possible as well by open source infrastructure, not to mention the materials and code in our very phones, this laptop, and all digital products. Open source and nature are both all around us, and this infrastructure is everywhere. There's some key differences, though, that have made it, I think, partially why digital infrastructure has not been supported and funded in the way our natural infrastructure is. And that's first, of course, the issue of how it's created. Open source is entirely human brain power, and nature is a result of the planet Earth and autocatalysis. This means a molecule can create its own formation, a key part of self-replication and how we got the genesis of nature on Earth. Don't you wish code could do that? Obviously, Open source does not have that benefit. When we go to the ephemeral versus the tangible, obviously nature is pretty tangible in the sense that it's made up of atoms. It's breathable, touchable, tangible. However, open source is not, when we consider, with the exclusion of hardware, software is exclusively ephemeral. It's very different to own code than to own a piece of natural resources due to the concrete corporal difference. Finally, when we talk about the end of life in these situations, handling death in open source is much more different and can be a lot messier than natural death. Obviously, when you have a project that can be sunset, or it can exist forever if forked and maintained. However, nature needs death. It relies on death in order to recycle that matter and create new life. Now, there are some requirements that both the digital infrastructure of open source and the natural resources require. And from an individual point of view, we can talk about fulfilling their needs through things like open source contributions, being a member of communities, maintaining projects, all the expertise you give when you come to events like this. It's all donated to the digital global good of a natural resource. However, we're able to attract people to do all that. I don't have an answer for that. That's $1 million question. Same with individual contributions to nature. When we talk about gardens, reducing meat intake, buying local, reducing plastic and oil dependence, those are pivotal and important steps as individuals to helping contribute back to natural resources. But asking people to do that on an individual level gets into the same question as open source. How do we ask people to do what we feel might be a duty that's not required? Institutions and systemic support. When we talk about this, I mean governments, corporations, foundations, and nonprofits that often provide both digital and natural resources with large contributions through things like resource promotion, programs, and funding to promote and support those resources. World Wildlife Fund and the International Union for Conservation of Nature exist in order to help foundations put funding into natural resources. Similarly, foundations like the Linux Foundation have created own sub-foundations to help support groups like in open source. So why aren't we seeing more money in individual contributions into this space? The challenges are things like governance. How should we operate and run nature and or projects? And to what extent is managing it versus controlling it? This is more of a macro and micro issue because you have the governance of a project versus the governance of a foundation, as well as the governance of like a park or an ecosystem versus the entire natural resources in the world. Then we have global warming, pretty self-explanatory. Rapidly melting ice caps, increasingly volatile and unpredictable weather affects nature, and nature affects how we're able to use our digital infrastructure. AI is also rapidly using water and open source as a free resource, frankly. Then we get back to that individual versus institutional contributions. As individuals, it's very easy to write off our own contributions, both in open source and in nature. We think, oh, it's just one PR or one commit, or it's just one time I didn't recycle, or that one time I threw a cigarette butt on the ground. What does it matter in the grand scheme of things when we think about what institutions could do with the programs and money and availability they have to offer our institutions? However, individual contributions are quick and easy and require absolutely zero governance, unlike the decisions made by foundations or governments, which require a lot more time, money, and labor to enact, and often are not long-term, unlike if an individual decides to make a habit out of picking up trash every time they go outside. Finally, we have government involvement. I know a lot has been said about the CRA already today, but we're starting to see more regulation and more oversight from the government and academic institutions in open source, and more outside opinions on what has been to this point a pretty insular community. Furthermore, as administrations begin to change, we're beginning to see different policies towards digital and natural resources emerge, and therefore fluctuations in funding and support. But there is a big advantage that open source has over natural resources, and that's the fact that it is made up of people who have voices. We can testify for ourselves, our own experiences, speak as our maintainers and as our communities as to what we need. Unfortunately, nature does not have that same ability, which means the best thing we can do, both for our natural resources and for open source, is to speak up for ourselves and say what's needed to those who can listen. And remember that individual contributions are just as important and big and changing as the big ones.
I want to show you a demo of the thing that I presented. Which is the FA Notify service thingy. Okay, so let's see. Let's start. I have a VM here. It has the tool FS Notify Wait installed. If you're running a recent distro, you probably have this tool already. So if you just run FS Notify Wait dash file system /tmp, but this could be any file system. Then and anything you do and /tmp, either read or write, you will get an event for it. And it can be a very large file system. And let's see. Yeah, that's what we have here. So I'm going to run a demo. What I did for the demo is I added an option -- server. Okay, so I can run the notification server as root, and I want to connect to this server to get file system notification as non-root. Okay, so let me just run the script, and then we'll go back to see what it had done. So okay, we ran this command, okay, -- file system -- server, created a Unix socket for clients to connect, and we're watching /tmp. vmtest is just a directory, but we're watching the entire file system. But let's see what we have there. So /tmp has this socket. It has this /vmtest directory that's owned by test user. So the purpose is to show I'm going to delegate to test user a way to watch its own subdirectory tree, right? But what's inside there? What's inside vmtest? Okay, we created it's mostly empty. So anything the user will create there, it will be allowed to watch. But we created, for the personal demo, we created the secrets directory. Right now it's world readable, writable, but it's owned by root. So it matters, we'll see shortly. So first thing I'm going to do, I'm going to run the client script right here as root, okay? And the client is just going to connect to the server. And then the script is going to run some operations, create deletes inside directories, and we will see the server will kind of send those events to the client, and the client will display them. What did I do? I ran the server script again. No? I hope. No. Let's do that again. Server. Okay. Client. Okay, so the client is connecting to the server, and then it had performed some operations. It created files, created directories and files, and then we see in the background that the service gets events for those files that were created, And here we see like a more deep structure that was created. So we see events for creation of directories. Do you see the path on the left-hand side? Created nested A, nested B. Okay, but how does the client know that this is the path where events happened? So actually the client gets two pieces of information, the file ID of the directory, and then the name B was created inside this directory. And then it's up for the client to resolve the path from the unique ID. By the way, the path could not exist by the time the event arrived. That will be seen as unknown, okay, stale. But basically, the client sees everything, can resolve all the directory IDs to path. So, like, we get everything, and in the end, yeah, we should have some events related to the secrets directory, right? Created some file in the secrets directory, etc., etc. Okay, done with that. Let's go into test user. Now I'm test user. I still have access to see the TMP directory, and it's owned by me. So let's see if I run the same script, client, I want to connect to the server, and request to get notification. So the demo server does not check anything. It allows anyone to connect. So it's not really going to be like that. This user is not supposed to be granted this permission, but let's see nevertheless what happens. So it's connecting, it's created all those file operations again, and it did get all the events because we were promiscuous and we allowed it to get them. But it cannot resolve the path, right? It sees that the password file was created, but it cannot resolve the path of this because it's not allowed to. It said fail to decode the directory file ID. Operation not permitted. Okay, so what are we going to do about this? We're going to spawn a user namespace for test user. And now, when test user looks at the TMP directory, it doesn't see the VM test file is owned by test user. It sees it as owned by root because there's an ID mapping, right? And how does the test user see the secrets directory inside? It sees him as nobody. That's an unmapped, an invalid mapping. So although it has permissions for world permissions to write, so this user can actually write to this secret directory, the rules that we apply to the kernel don't allow it to decode the file. It allows it to decode the path only if the entire path is mappable. Those are the rules. So if you run the script from inside here, we will see that all the paths are being correctly resolved. Why? Because unlike the test before we entered the user namespace, now when this user requests to resolve some file ID, the kernel goes and checks the entire path and sees that the entire path is owned by user that is mappable to this namespace, and the resolving is allowed. So yeah, he gets the path and can display it, but in the end, number 7, creating secret files, we don't see that. We don't see those events. Because all those events happen inside the secrets directory, which is owned by a non-mappable user. So the client did get the events, but the resolving did not succeed, so they're not displayed here, right? We can do more filtering in the kernel even, but that's currently what's done. And the idea is if an orchestrator will allow you as a non-root user to mount some image, for example, because it's empty, and make a fast image owned by you as root, ID mapped. It allows you to mount it, and then you can, yeah, you can provision it to do anything, right? But the kernel only makes sure that all the files, all the inodes in the system are mappable to the namespace. And that's the minimum it has to do. And that's it.
So this is a short version of a talk I gave at the main conference. Has anybody been to that talk? A few. Okay, so yes, no? So I'll keep it short. I think I'll reserve more time for questions at the end. So if you look at what some large companies publish that their utilization is, it is relatively low. It's between 20 and 40% is what they published. And these are big companies that have a lot of resources to optimize their CPU utilization. But what happened more recently is that some companies have been able to achieve higher utilizations. For example, Google went up from 35% to around 50%. So that's 50% more CPU utilization. If you look at what are the contributors, I was able to find two major contributors. One is that they were able to bin pack more containers into the same systems. And another one is that they were able to handle the interactions between these packed containers and still keep good performance even with the higher density. And that allowed them to get to the higher utilization. And this is what I'm going to talk about. There's been a lot of research in the last few years about this. There's been many papers published by those hyperscalers in well-known universities. And I think there's enough for our community to plumb our containers in a way that achieves this higher performance. My background, I did my PhD in noisy neighbor mitigation, specifically network. I then founded a company where we built eBPF-based network monitoring tools, which then we sold to Splunk, and that project became the OpenTelemetry network project, and now I'm working on noisy neighbor mitigation. So how would one of these noisy neighbors, one class look like, the cache noisy neighbors? Your application might fit into caches this way. Your different working sets with different intensities fit into the different hierarchies of cache. So you have fast, like what you really need most fits in fast cache, and then slower and slower caches are larger. A noisy neighbor might use memory very aggressively and evict your process from shared caches, which means now your application has to go to slow memory in order to access its memory so that the application becomes slower. And there's another class of it where if it runs very close to you, then it evicts more caches, and now you suffer more. And this can be very substantial. It could be 5 times to 50 times slower access to memory because you have to access the higher tiers. MIT researchers ran this experiment where they ran Memcache with a garbage collected workload. Through this experiment, memory bandwidth is relatively low until the garbage collected workload goes into the mark phase. And then it's very memory intensive. And that causes the latency, which is usually very predictable and low, around 50 microseconds, 99.9th percentile, to spike up 3 orders of magnitude. So this is actually, has been shown to be really bad. And this means that, any workload could be noisy neighbor. We ran this test. We spun up this test environment based on OpenTelemetry, the OpenTelemetry demo, which has around 20 services written in 13 different languages to measure these effects ourselves. And what we did is we measured this metric, cycles per instructions. So you measure the number of instructions that you want to execute, and then cycles is how many ticks it took, so the time it took to execute those instructions. The idea is if you have high interference and your application is kicked out of caches, then running some instructions takes a lot of cycles. It takes a long time, so the ratio is going to be high. If there's no interference or little interference, then it doesn't take as much time, so this metric is going to be low. And we found that a lot of the services have slowdowns when there's high contention for memory. And we found 20 to 30% slowdowns for most services and up to 3 times for some others. If you look at, this requires a little bit of explanation. What we did is we took a process, and then that process, processes get scheduled on the CPU and taken off the CPU when they do I/O, for example, a network call, right? So the scheduler schedulers you on, then you do a system call, you get scheduled out. And what this graph shows is we took a trace of all of these scheduling on and off, and we measured what is the CPI after different times, right? Like we didn't change those times, but we measured, on a big trace, we saw for different times of being off the CPU, what is the CPI, and the red here is the mean. And you can see that when you're scheduled out of the CPU for longer, when you're scheduled back, you have higher CPI, so you're less effective, which supports this hypothesis that kind of caches really matter. Just a fine point, this doesn't measure the amount of time that you're scheduled off the CPU, but the amount of CPU time that everybody else on the system was scheduled on the CPU. So this is the amount of work that others did while you were away. So the more that other processes do work, they evict you out of cache, is the hypothesis that we're seeing here. It matters because if you see these two simulated systems, one with low load and one with high load, the high load system has more of these interference events, these garbage collection events, right? Like, so it would have worse performance. And we've been programmed to, or operators have been programmed when they see the bad performance, high load, they scale out. So they move to the low load, right? So this is very wasteful. Can we just solve this? The way we could solve this is by measuring, seeing who is using more than their fair share, and then throttling them. And in fact, Google and Alibaba, which are the two companies which I've shown you the higher utilization, have published that they have systems like these. So how do we get to measuring this? The problem is that the events are very frequent. Garbage collections might take between a millisecond and 100 milliseconds. And if you simulate such a system, then you see if you sample every 10 milliseconds, you see something. If you aggregate over a second, all the signal is gone. So you really want to measure very frequently, and that is relatively hard. There are no observability solutions that do this, as far as I know. So we set out to build one, which is what I wanted to show you. And so we built it, and here you can see it on a live system. That's the OpenTelemetry demo, 96-core system. Here you can see 1 millisecond measurements of cache misses per process. So on the legend here has the different processes in the system. And here you can see an anomaly. One of the processes is causing a lot of cache misses. If I put this graph in the top and look in the bottom, I'll add the total memory bandwidth in the system, the cache misses and hits together. You can see that at the same time, there's a reduction in overall system efficiency. The system is not able to read as much memory, which, this is what we're trying to avoid, right? Like everybody became slower during that period. You can deploy this. It's open source under an Apache 2 license. There's a Helm chart, and the details are available. This is the repository, and I'd like to invite you to join and contribute to the project. It's written in eBPF and Rust, and there's a bunch to do, and we'd love help. And even if you want to run the collector and give us feedback, that will be great. Our contact details are on the README, so feel free to reach out. And I hope this helps us get to this higher performance in the community. And with that, yeah, I hope we'll not be the fail dog, right? Like where kind of everything's burning, everything's noisy around us, and we still say this is fine. With that, thank you. Happy to take questions.
Just one question. I'm not an expert in memory, but I work with telecom customers and they use isolated CPUs with a lot of huge pages. So there's, I mean, Kubernetes by itself does not allocate. I mean, like given that you give huge bills or not, you cannot say that this port gets memory from a specific cache, right? So how does this affect normally when you have when you're using DPDK-based memory access for your ports?
Okay, you're asking about these types of applications with DPDK on Kubernetes, and does Kubernetes support control over where you allocate memory and how much cache you get? Currently, Kubernetes doesn't support that control, although there has been recent work on specifying to Kubernetes where to place workloads. So AMD has this architecture with, I think, chiplets, or how is it called? They have these different domains, and you can specify, I want this workload to run on those cores, and I think the kernel would prefer to allocate memory from that. But other than that, kind of controlling how much cache you get, there's no way to declaratively do this today. Thanks.
Yeah, so let's just do something very short and just fast. So let's say that we want to run a Docker container with Nginx anything, right? Just a normal container. What we would do? Docker run Nginx Alpine, right?
Yes, that's one.
You're correct.
No. That was over.
Okay, yeah. Okay, we cannot find daemons locally. We'll get daemons. Oh, Galway exists, and we'll just run the container, right? Easy peasy. So, if we want to do the same thing, for example, with Linux, right? We have here, for example, next Linux. Let's do it with Firecracker. So, we already have here a kernel that we have already built. You can see it's around 22 megabytes. It's a big kernel because it's the Kata kernel. We can restrict it even more. We can make it like 10 megabytes of the kernel. We can easily reduce it. So how we can do it with URNC? As I said in the talk, we need to add something we need to add the kernel inside the daemons. And to do that, we provide a small tool. We call it Bunny. It's simply just you define here the rootfs. We say here that we want to use the Nginx Alpine image as the rootfs. The type will be raw, which means that we want to mount the whole rootfs inside the VM, and that's going to be the rootfs. And we also specify the kernel to be the VM Linux that we have locally. Okay, pretty simple. And then we have the CLI here. That's what it does. Oh, and here we have also defined that we want to run it on top of Firecracker. This is information necessary for URNC. So what we're going to do here is just docker build. Let's name it URNC Nginx Firecracker Alpine, and we will just build it. What happens now is Bunny will just make everything, and we'll just put the kernel inside the daemons, and we set some specific annotations that URNC can understand in order to boot the daemons. So let's try and run and see what's going to happen. What we're going to do is simply specify the runtime to be different one. And that's it. And we failed. And we failed because we don't get the The kernel could not be open. Okay, so I think I have the wrong. Yeah. Oh, wait a minute. That's weird. Okay, let's try to do the same thing for. I think it's because we cannot find the kernel path. Okay, so let's try to do that with a different image. Let's try to do it with the Unicraft. So we have here again a bunny file. This is a different thing. This is the we run the Unicraft Nginx stuff. So what we're gonna do here is again we're gonna build it. Here, let me see what was it. It was Chem1. So what happens here is that we pull the image from Unicraft catalog. So this is a different process. We will go back to Linux later, just to make sure that everything is set up correctly. I don't know if this is a test environment. So just want to make sure that this runs correctly. Okay, yeah. So this is now we have everything is okay. So if we do a Docker PS, we'll get here that we will see that we're running the Nginx Cemu Alpine. That it seems that I didn't change the name, and this is the unikernel. So if I do even a PS, I will get the Cemu. I will see that I have a Cemu process running here. And we can see that if I get all the namespaces that I have right now in my system, I can see that the Cemu is running in own namespaces which are different from the namespaces that we have for the system. So what happens is that uRunC applies all the OCI specification to the monitor process, and then it spawns the kernel, the unikernel inside this monitor process. So let's try and go back to the Linux case. Let's stop the one that we had. Okay, so let's make sure everything's okay. Now what we're gonna do, I think I have somewhere, let me see. Maybe, yeah, maybe the Alpine Cemu we can try. I don't know if. Okay, so let's try this one. So again, this is a bunny file that we have, and we want to include something in the rootfs. Okay, so we have we want to get the Nginx again rootfs, and we want to add something in the rootfs, something like uRunit. uRunit is a simple init process, like for example, like Tiny or any other kind of stuff, but is specialized for uRunC in order to understand some more complex arguments that we passed through kernel boot params. So if we do here, and also we see that we specify the init to be our entry point and CMD will be BNSAs. Okay, so if we build this one, first, simplicity, let's just do that. And if we do a docker run, okay, we see we're running a Linux VM right now, and we are inside the. This takes some time because we have a lot of logs. We are running only one. We have only one thread here, and I can show you that the memory is the same memory that we specify for the container. It's the same memory that we specify for the Cemu process. So you can see here that we have only 256 megabytes, which is a default memory. And here we can get this one. We can see we're running a different kernel from the host system, which is this one. Okay. And again, if I do, I see that I have again different namespaces for this running Cemu process. Also, if I try to do this one. Help me if I am doing something wrong. This guy. Yeah, maybe I don't do something correctly. Okay. Yes, that is correct. No such file or directory, which means because inside the CH root, the rootfs that we have for where we're running the monitor process, we don't have anything. It's only the monitor binary, nothing else. And of course the container rootfs, right? Because we need that. So we don't mount anything from the host. We just get only the QEMU binary from the host. We have to specify where the QEMU binary is. Right now, we are working on having some configuration in order to have different paths for the QEMU binary. But right now, we just search the path and find where the monitor binary is, and we can run it. Okay, so yeah, that's it. And just to verify, we are having a different kernel here than the one that we run inside here. And again, you can see that this is a very, very minimal thing. Like our init process is very, very minimal. We don't do anything inside the VM, just run the container. And yeah, we this of course runs KVM. I would like to show you maybe if you're interested or not. Okay, I can maybe show you some. I don't know if we have it here. Maybe the red run. No, it's a SPT one, but we have it in the simple images. So here we have some already unikernel images that you can use. So what I want to show you is this guy. So this is Miraz. Miraz is in a COML unikernel, which means everything is written in a COML. And we can run it on top of, we can run it on top of, again, we can do Docker run. And we run it on top of Solo 5 SPT. Solo 5 SPT is a very small, tiny unikernel. You can see how fast it boots. It's a very tiny monitor process. It uses a comp filters. Like it kind of resembles the architecture of gvisor. It only allows 5 system calls, only for block and networking. And yeah, this is a network stuff. So we can do a PS here, not this one, and we can do an inspect to get the IP of this one. Okay, and here is the IP. So if we do a curl here, yeah, connection refused because I think it listens to a different port. If someone can find any port here. No one. Yeah. Okay, maybe here somewhere. No. Anyway, let's just do curl. Let's just do a ping. Just to show that the network is working. So here you can also get the logs that we have some ping requests. I don't remember the port right now, but there is a specific port that this unikernel is listening to. And of course we can manage it and just stop it like any other kind of container. So yeah, that's all. If you want something, again, this also works with Kubernetes and stuff. We also have a URNC deploy, which allows you to just do deployment over Kubernetes, and you can just run everything there. It will install everything and customize containerd for you. So yeah, just if you want something more, just come and talk to me, and we can have a chat, or I can show you in private something more while I'm trying to figure out what went wrong in Firecracker. Okay.
Since it was originally like as just an internal presentation, I don't have like a standard introduction slide. So just for context, in the like Garden Linux is sort of SAP's own developed Linux distribution for Kubernetes workloads. But the main part, what this is about, is like when we're building our disk images, we want to be able to kind of build the rootfs without having any elevator privileges. So the idea is we want to be able to build disk images on any dev machine, even if you don't have root on there, without any further permissions, nothing. So we considered first, we could just build inside a virtual machine, kind of gives you highest level of control, all that. You can really abstract everything away, but then you need access to dev KVM, so you either need to be root or have a user that's specifically configured to have access permissions there. Doesn't really fit our need. You can run QEMU in emulation mode, but have fun building entire distro image that way. That will take forever. Normal approach would then be using like fake root, fake change root, that stuff. Totally implemented in user space, so privileges-wise, that works great, but the second you get into cross-architecture stuff, not so great. You want to run Go binaries during your build steps, again, not gonna work, because then this whole LD preload logic is just going to fail. So in the end, we decided we use unprivileged containers, because, everyone likes containers, and if you use the unprivileged rootless version with user namespaces, you don't need to worry about all the needing elevated privileges. Isolation is nicely handled by the kernel for you, and as long as you have the bin format misc handlers installed, you can even do cross-architecture stuff, so really ideal for us. The problem there is now we also want to build images that have SE-Linux support, so that the image, inside the final image that we built, it should be using SE-Linux, and that means during build time we need to set all those SE-Linux contexts on all the files. And what happens if you start an unprivileged container and try to set that? You get some operation not permitted. If we look into where this is doing it, you look into the kernel, you dig through all the syscalls of what is doing the set extended attributes calls, you go down all of this chain, that will eventually also call some LSM modules, but we get to that later. The important part is there, it's doing a check on if you have some cap sysadmin, so looking at that you might now guess, well, then you're just out of luck, no way to set those extended attributes. Luckily, it's not looking at global cap sysadmin, it's only looking if in your namespace you have the sysadmin capabilities. Right, so we just create a tempfs that's inside your current namespace, then set the extended attributes in there, and it all works perfectly fine, as you would expect, nice and easy. Now is the point where you enable SE-Linux on your build machine, because I said before we want that anyone is able to build this on any build machine regardless of how it's set up, so that means even if your build machine has SE-Linux enabled, it should work. Try that whole thing again and not looking so nice. Especially if you look at this command and you see there's an invalid argument, if you've played around with extended attributes before, that might confuse you. So you strace that, and it is actually the setXattribute syscall that's returning invalid argument. But if you look at the man page for it, it shouldn't. It's not anywhere on the list of return codes that setXattr should ever return. So I dug into that, and I already gave a spoiler for that before, that this at some point also calls into LSM modules. If you look in there, if you have SE-Linux enabled, those additional calls are made, and all the way down there in this chain, it is trying to resolve the context that you gave it to some internal ID, and if that one isn't available, then it's returning invalid argument, despite that not actually even being a valid return code for that syscall. So that's kind of where it's breaking. It's not even that SE-Linux is preventing you from setting this. If I had done the same example with a context that whatever profile was loaded at the moment SE-Linux understood, could translate to an ID, in the next step it would then realize, oh, you're allowed to do that on your tempfs, nice and fine. But since we tried this with some context that just wasn't known to the policy loaded at the time, you get this lovely invalid argument. So the workaround, we just intercept all extended attribute related syscalls, emulate them fully in user space. One way you can do that is with like some fake root, LD preload. As I mentioned before, as soon as you do cross-architecture stuff, really painful. If you do it with Go binaries, won't work. So might do ptrace, would work, yes. You could do all of this with ptrace to emulate that, but following ptrace across forks and also with multi-architecture again, definitely doable, but really difficult. So what we used instead is this seccomp unotify. It's really nice way how, similar how with normal seccomp you can specify BPF filters to kind of look at each syscall and then in a BPF filter program decide, do I want to allow this, do I not want to allow this? Seccomp unotify lets you instead say in that filter, actually, I'm not deciding, pass this to the following user space program and let that one decide. So the way that works is when the target process is making any kind of syscall, that goes into this BPF filter, and then the filter is not returning either a yes, let this through, or no, but instead it's just saying, hey, actually forward that into user space. That's sort of then going through some listening file descriptor that the user space daemon has opened, that gets the request, and then your supervisor program can decide what to do with it. Deny it, allow it, although the documentation says you shouldn't rely on the deny capability of this because might be workarounds. But the really nice part is you can also let it just return some arbitrary return values. So you can just fake doing the syscall without actually having the permissions to really do it. And that's what we're doing. So we're just pretending we're making those set extended attribute syscalls, returning whatever response sort of the target process was expecting without ever actually performing the syscalls that we don't have the permissions for. So if we now run the example from before with that one, it just perfectly fine sets that context the way you would expect. So how this works sort of more internally is with like the filter, with the notify file descriptor, and then the supervisor process has like a loop where it's just waiting for any kind of syscall, then has something that handles them, and instead of directly setting them on the real files, this one just has a database, which is a mapping of like file system and inode number mapped to some extended attribute table that's just stored in normal user space memory, and then if you make a set extended attribute call, it writes in there. If you want to read one, it reads back out from there. So that way we can emulate those without ever needing any real permissions to do that on the file system. Yeah, this is some small nice side note. Just if you want to build something like this yourself, just a tip from my side, like the normal explanations on seccomp unotify tell you that you should use some Unix domain sockets to kind of pass back the file descriptor from your target process to the supervisor process, use some notification mechanism that way to instruct it, hey, I'm ready now, you can start listening on this. Works, but then you have like 200 lines of boilerplate code just to get it running. I figured out there's a nice trick if before you start your target process, you clone it with vfork and files shared, then your supervisor process, because of the vfork part, is automatically frozen and halted at that point until your target does an exec call. Then you can just set up the filter in there. Since the file descriptors are still shared at that point, the supervisor just magically has that file descriptor. And now you just unshare with the clone files in there to no longer have a shared file descriptor space. Then you do an exec, and that way automatically, because the prior clone was done with vfork, the supervisor automatically returns at that point. No need for like some fancy additional synchronization mechanisms. That's just if you want to do something with seccomp unotify yourself, that trick is quite handy. And if you want to use that tool to do something in containers where you want to set extended attributes, but you normally couldn't, there's the link. Feel free to try it out. Thanks. Yep.
So this works because when
what you're doing later with that file system is you're packing in or something.
Yeah, exactly. Like the idea is in a step later, I think. Let's see. Like here in this example, like this is just a simple proof of concept where you're setting it and then afterwards you're listing it and it shows whatever you set, like it returns the emulated result. If I ran tar on this, it would also read the emulated result. So yeah, that's exactly like we're creating this, then we're tarring it, and as long as the tar process is also gets the emulated syscalls to believe that those were the right attributes, it's fine. Yep, exactly.
And so you started this by saying you wanted unprivileged
Yep.
creating, but just that step of setting up the supervisor is privileged?
No, it's not. Because you can create a seccomp filter in a user namespace. You only need capsysadmin in a user namespace for this. You don't need any real root at any point to run this tool. Obviously, you need the permission to create an unprivileged user namespace. I mean, if that's disabled in the kernel, then no luck. But as long as you can do that, it works. Yeah.
That's great. Do you know about the thing that we did with OverlayFest that does Exadata translations? It was done for, I don't remember the name of this project, ComposerFest, right?
Yeah.
So ComposerFest uses extended attributes, and they wanted to be able to compose the images inside an unprivileged namespace. So there's a feature that if you're running OverlayFest like for using this with the -- user etc, that it translates the exatters that you write
To the user dot. Yeah.
It doesn't do it generally for seccomp. It just does that for the OverlayFest exatters, so that ComposerFest could write them. But I mean, it's
Would
not
have
that-
to look at, like, at the time when I did this, it certainly wouldn't have worked, because that's also why we have this database and not just use the user dot something.
It wouldn't help you, just so you know that's
Because the like support for user dot something extended attributes in TempFS is quite new, so that's also why here we have the database and don't just use the user dot whatever extended attributes on a TempFS, because when this was built, that feature just wasn't even in the kernel yet. With that, maybe that would work. I'd need to try like whether SE Linux would get in your way there or not. I have no idea.
user exatters, I don't think you know.
Yeah, like I'm not sure at what point that translation would happen and at what point SE Linux would look into it. Like maybe it works. I need to try that. Yeah, but good point. Thanks.
The eBPF would just be easy. You just strap anything, you strap user to.
Ah, you mean just rewriting it at that point? Oh yeah, that could work. Yeah, good point. Yeah.
And just as a, it's not, I don't know if it's really critical, but if your Xadder strategy was very simple, you only wanted this specific Xadder, everything, you'd be able to just have the read side.
Yeah. I mean, you could then, but we actually want to apply like a proper, the normal tool that just sets it on an entire root file system based on some definition files with arbitrary context in there, whatever it might be. So that's why we need this with the whole database. But yeah, if you just want to always fake that everything has the following fixed SE Linux context, yeah, you can just implement the set routines only and the rest just always returns. Yeah, I've done that without actually doing stuff. That would work, yeah.
All right. Thank you.
Thanks.
Okay, let's gather around the fire for our Halloween story. I'm going to start at the end. This is where I'm heading to. This is a test for FR routing. And you see at the right here is a network topology. There's 4 routers and a bunch of switches. And we need to get there somehow. And you can see this is a test report, a bunch of log messages. And to do that, we have a bunch of PyTest integration. That doesn't tell you anything yet. But let me show you how this looks like when you look at the processes. because you can see, okay, there's an unshare at the beginning. There's a few more unshares, and then stuff running in there. So what we're doing here, and let me switch to my notes. What we're doing here is we need to test FRR after it's built. It's a bunch of binaries lying around in the developer's disk. We have the existing tests written in Python. And the way we got there is kind of cursed. Because what's happening here is this is reusing the host's file system multiple times, because that's where the software was compiled. And to make that work properly, some places in the file system get overmounted with the tmpfs, which I can also show you. Yeah. So you can see here, no, it's too far up. So these are things inside of the container that have been replaced with the tmpfs. And we are planning to go to use overlayfs instead. That at the beginning, there was some reason that didn't work. I don't remember what it was. It was like 8 years ago. The entire thing does run as non-root, but it only has one user namespace. So it only at the very beginning, it changes into user space, a namespace for the entire test system, and it stays in that the entire time. Inside of that user namespace, each of these routers that you saw at the very beginning is a separate network namespace, mount namespace, PID namespace, but not user namespace. And the test system is really intrusive on these namespaces. So the logs that you saw in the HTML report get directly transferred out from the daemons running inside over sockets that were passed when the process was initially started. We are also mucking around inside of the network namespaces to get packets in there. And the test actions defined in the test that we're doing is just go into the network namespaces, do random things, call things, start new processes. We don't use cgroups, we don't use seccomp. Isolation, well, if the test overwrites your home directory, oops, there's nothing preventing that. We did run into a few problems. For example, we tried to use the netlink connector, which allows you to get notifications of process start and fork and exit, but that doesn't seem to be namespace aware yet. I haven't rechecked recently, but it was still the case a year ago. And also, every container kind of has this problem with network namespaces. If you do network heavy things, the RTNL lock, it used to be global. It's being worked on right now to make it per network namespace. And if you have a lot of things doing network operations, you get a lot of lock contention on that. And it's just a really cursed way of doing all of these things, I think. It's containers, but it's not really containers. It's just hacking around. We do also support FreeBSD, which makes this even worse. It's Rails there. And that's all I wanted to show you. And as a final gimmick, I have a question. Do you think you can bind mount over a symlink? Does anyone know the answer? The answer? Current kernel. Actually, it didn't change recently. It's been the same for a few years. So the answer is yes, but you can't do it with the mount tool. You need to write your own tool and pass different flags to the kernel. And we learned that by trying to replace /dev/log for this setup, and that is a symlink, and trying to mount over that is not something you can do with normal mount. And finally, this is the actual code doing some of this in Python. So yeah, I don't know. Maybe I can roast some marshmallows on top of this. Yeah, I don't know. And that's it. I hope you have a horror story to take home. Share it with your colleagues on October 31st or something. And good luck.
So we're done for today. We kind of adjusted the schedule. Of course, we're happy to chat and stick around and all that kind of stuff. But I want to say again, thanks for coming to Container Plumbing Day Starting Summit. I hope to see some of you, or all of you actually, back on the Open Container Initiative Slack, which, as we learned today, is not part of the CNCF Slack. It's a separate Slack, but Very excited if you would join us there. And let us know how you thought, what you thought about the program today. If you have feedback, if you would like to see something else, another summit, let us know. Very happy to take that. Yeah, thank you again for coming.